Hello students, welcome back to geometry. Today we're going to talk about proofs using congruent triangles. That's a really fancy way of saying that we're going to be introducing a concept called CPCTC. There's really just one little thing that we're adding on. So I'm just gonna dive right into that. And here's the idea here. So let's say that I have a triangle, and you know what? I'm gonna cheat and I'm gonna use my technology here to make a real triangle. Then I'm going to copy it so I actually have a congruent triangle. Oh look, it brought the text with it too. That's nice. Okay, so let's say that I have triangle A, B, C, and triangle D, E, F. We have done a lot of working on proving that two triangles are congruent. But what if we already know that they're congruent? So we've done all of our work with our SAS and our ASA, and we've proved that these two triangles are congruent. Well, let's say, for example, that I have proven that angle B is congruent to angle E, and angle A is congruent to angle D, and side AB is congruent to side DE. Well, I could now say that these triangles have to be congruent because of the ASA congruence theorem. However, by definition of congruence, that means all of the corresponding parts would then have to be congruent. So if I've already proven that these two triangles are congruent, I could now say that angle C has to be congruent to angle F. So that is where this theorem comes in. So this theorem is called corresponding parts of congruent triangles are congruent. Or you're allowed to use the abbreviation CPCTC. And that just means that if two triangles are congruent, then their corresponding parts must be congruent. Okay, so I'm just going to dive right into an example from the homework. Nope, not you. Hang on one second. Okay, so here's an example. So, explain how you can use the given information to prove that the hang glider parts are congruent. So, looking at these triangles, I see angle 1 is congruent to angle 2, and angle RTQ is congruent to angle RTS. But what I would like to prove is that segment QT is congruent to segment ST. So, if we had done this problem last week, instead of proving that those two sides are congruent, what we would be proving is we'd be proving that triangle TRQ is congruent to triangle TRS. So the strategy here is to prove that the two triangles are congruent, and then once the triangles are congruent, then their parts have to be congruent. So let's go ahead and do that. I'm going to draw this separately because I think I will be able to look at this easier. That is not my best triangle. Picture not drawn to scale. QRST. Okay, so now first thing, angle 1 is congruent to angle 2. So, switch colors real quick. Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Given. Step 2. angle RTQ is congruent to angle RTS, so that would be RTQ is right here, and RTS is right here. Angle RTQ is congruent to angle RTS, given. I don't know why I put T at the end of that. Okay, and now, hopefully, you guys are used to this piece. Right here, I've got RT is a part of both triangles, so I can say that RT is congruent to itself. And the reason for that is because of the reflexive property. Now, looking at what I have here, I have angle, angle, and then side. So angle, angle, side is used to show that triangles are congruent. I can say triangle TRQ is congruent to triangle TRS. The reason for that is because of angle, angle, side congruence theorem. Now, once we've said that the triangles are congruent, that means that all of the individual pieces of the triangles have to be congruent. So I can wrap that up, step 5, just by saying, well, since the triangles are congruent, then their corresponding parts must be congruent, which means, switching colors again, that side QT must be congruent to side ST. So I can say QT is congruent to ST. And that is because corresponding parts of congruent triangles are congruent.